Good morning. Thanks for getting up early to be here with us, even despite the fact that some of our thunder might have been stolen by the 3 or 4 presentations before this that demoed the navigation editor. Luckily, we have time to go into a little bit more detail than any of the previous presentations, so there's a lot of good material here. And I'm Lukas, product manager for architecture components, and with me I have Ian and Sergey, who built the navigation component. And navigation, if you think about it, is a problem that pretty much every app on Android has to solve. But until now, we haven't really given you anything to do that with other than start activity, which for various reasons is not the best way to go about that. So if you think about our job of making Android development easier, navigation was a common problem with no real solution. And that means that there are a lot of things that you have to solve on your own. And those range from how to commit fragment transactions, hopefully without throwing an exception, how to test that navigation is happening correctly and that the right things are happening when navigation occurs, how to map deep links to various places in your app, and how to keep those deep link schemes up to date as your app navigational structure changes. Passing arguments from place to place. Again, we don't give you a type-safe way to do that today. How to make sure that up and back take users to the right places, particularly in sort of more difficult situations, like someone deep linking deep into your app's navigation hierarchy. And so what this means is by the time you finish solving these problems, you've typically gone one of 2 directions. You've either written 60% of a navigation framework, or you've got a lot of error-prone boilerplate everywhere navigation needs to happen in your app. So you've got a bunch of parallel lines of code solving these various problems, and the whole structure is fairly brittle. And that's why and individually, these problems are pretty tractable. But if you look at kind of a real-world example, you can see that they can get pretty hairy. So say that I have an item screen in my app, and it's accessible via deep link. So far, so good. But if someone had navigated to this screen via opening the app from the home screen, they would have a couple other screens on the back stack. And so hitting it up, we want them to take that not out of the app from the item screen. We want them to go to the category screen and then the home screen. And that means that if someone deep links into the app, we need to synthesize these screens and add them to the up stack before showing the item screen. And talking to a third-party developer, he told me it's when you're in the middle of writing the code to do this, to synthesize these screens and add them to the up and back stack, but only on a deep link, that's when you start to feel like maybe you're solving a failure of the framework. So it's to help solve problems like that we're launching navigation. And what we're giving you is a visual tool that lets you edit the navigation graph of your app, which is represented in XML. And that lets you define a set of available navigation actions, arguments you can pass from place to place, things like visual transitions. And then a single navigate call activates all of that at runtime. And so last but not least, that means one thing you never have to worry about again is touching a fragment transaction with your bare hands. So the navigation graph is essentially just a set of what are the possible destinations people can reach in my app. And those usually correspond to screens, but not always. So you can have the navigation controller just changing the contents of a smaller part of the screen. But it's a set of navigation destinations and the actions that link them. And the actions really represent how you can get from place to place. So to actually navigate from point A to point B in an app, you're just going to call the correct navigation action at runtime. So let's take a look at what this looks like. And let's switch over to the demo. OK, so what we see here is a set of navigation destinations. And these are fragment destinations, although other options are possible. And the lines connecting them with the arrowheads are actions. And those actions actually generate methods that you can call at runtime. This whole thing is backed by XML, as you all know and love. And the XML and the navigation editor have the same set of capabilities, so you can use either one. We're going to add a screen here. And what you're seeing is a set of available activities and fragments in my app. OK, so we just added an option for them to actually answer this question successfully and win the game. So now we're going to add an action to navigate to that screen. Great. And so that navigation action has a bunch of options that you can set, obviously. We're going to talk about those a little bit more. For now, we're going to do one thing. So we're going to say, if they've gotten to this congratulations screen, that means the game is over. So hitting back shouldn't take them back into a game that no longer exists. So what that means is we want to, on that action, say, let's pop to the match screen. And that means I'm going to pop off everything on the back stack in between this destination and the match screen. So when the user gets to the congratulations screen, when they hit back, they're just going to go straight to the match screen. So a lot of other options I can set, but we'll just talk about that for now. Let's go back and look at the congratulations screen again. One other thing to mention, that the key thing that is set here is the fragment class. And that's what's actually instantiated at runtime. And we see layout previews here because the navigation editor knows what layout is associated with that navigation graph. And because it knows what layout is associated with that navigation graph, I can double-click on that fragment destination to get here into the layout editor. Great. And everything that I've just done here, adding this new destination to the navigation graph, an action, changing what the pop behavior of that action is, all this stuff I can also do programmatically at runtime. So navigation editor, XML, or programmatic all work just fine. Great. And now I'm going to hand this off to Ian to walk you through this in more detail.
So the first question that might come to mind is, wow, this is a totally new way of kind of structuring the UI of your app. And kind of brings up this question immediately of like, OK, so what is my activity actually meant to do? Right? So every kind of app has a very different starting point from where you guys are right now, or maybe as of 2 days ago, on how you've kind of structured the UI of your app. Some may be very activity-heavy, very fragment-heavy, very much in a different system. All of those are certainly very valid places to be. But we're moving towards a model where the activity is more just an entry point into your app, rather than the activity being the owner of the content of your app. It's actually just what's going to store kind of that global state. So the global navigation, so if you have bottom nav, navigation drawers, if you're still using an action bar, those are the kind of things that activities manage. But it delegates to what we call a nav host for content. So our nice, super simple activity here, we have an action bar on the top, a bottom nav on the bottom, and this big white box in the middle, that's our nav host. So in the world of navigation, when you navigate between different destinations in your app, what you're actually doing is just replacing everything inside that box. Right? So you have kind of that global navigation outside of that. And we have hooks that you can hook that up to stay in sync with the actual nav host. So what does a super simple version of this look like? Well, if you're using Fragments for destinations, you want to use our nav host fragment. So here we just have a activity layout that is literally just our one fragment. So you do this by including the navigation fragment dependency, as you might expect. If you're using a totally different kind of destination, it would probably also have a different kind of nav host that you add here, whether it's a custom view or whatever other item that they need. But for nav host fragment, we've kind of set up a few convenience methods. The ability to set what navigation graph you're using in XML, so you don't need to do anything programmatically to set it up. It'll just go to the start destination of your graph by default. And then for fragments, we can actually hook this up to the system back button. So we offer a method to do exactly that. So you don't have to override on back pressed specifically for navigation. We'll kind of hook up all that stuff using the magic of fragments through this default nav host option. So that means that our activity actually gets to be 2 lines of code. It would be 2 lines, but it doesn't fit horizontally on a slide. But all we need to do is just inflate our layouts, that content view, and then hook up the up button. Now, normally this is a large operation, but because you've told us about the structure of your graph, what we can do is, in this case, we're using a Kotlin extension method on activity. It'll just be a static method for Java users that allows us to find the navigation controller by passing in the ID, in this case, the ID of our nav host fragment. And that just gives us access to navigate up. And navigate up is going to do the right thing based on your navigation graph. You don't need to actually do a lot of extra work here. By giving us your graph, we are able to do this for you. But for most apps, just having a single thing is not actually what you have. Maybe you have something a little bit more. So we've kind of set up a second dependency, navigation UI, which is really just a set of static methods that connect your navigation component with some of the material design components. Some of these things like bottom nav and things like that that are very much in that kind of global navigation space. But of course, it's 2018, so we have KTX, one that changes those static methods into extension methods on the classes that they operate on. So this is really easy for Kotlin users to kind of integrate into your app and have navigation feel like it's just something that exists in all of the components that are out there. So what does this look like? If we, again, kind of make our navigation or our activity a little bit more complicated, we'll add a toolbar on the top, and then we'll add a bottom navigation view. And in this case, we still have the same kind of app menu that you had before on a bottom navigation view. But what we do to kind of hook those things up, it takes 2 parts. One, your menu here is actually going to be using the same IDs that you've had on each destination. So each destination has a unique ID. And we can actually use those same IDs on your menu items. So that kind of builds this implicit link of, oh, well, if you click the home menu item, you're going to go to the home destination of your app. So in code, we're just going to set up our action bar using our toolbar. And then we can do the same find nav controller to get our access to the nav controller object. And then we just have a Kotlin extension for activity that allows you to say, set up action bar with nav controller. And this does quite a bit of magic. But what it's doing is it's actually going to be receiving events on when you've navigated in your nav controller and using the labels that you've set up in your navigation graph to update the title of your action bar. And we also have another helper method if you're using a drawer layout to automatically change it from a hamburger button into a back arrow based on what destination you're on. So really kind of just those helpful patterns to make sure that those things stay in sync. Similarly, for the bottom nav, you just call setup. You call setup with nav controller, and we do the 2-way syncing here. So as you click on things in the bottom nav, it'll change the graph and do the correct transition based on the material guidelines, as well as you navigate between your app, if you have separate buttons, it'll actually update the selected item in the bottom navigation. So this gives us a lot of power, but not everyone is just using pre-built components that another team has provided. You have your own custom UI, right? So at that point, we really need to go deeper into what nav controller actually gives you. And for the super simple case, you have a button, you want it to go somewhere. We have a convenience method, create navigate on click listener. You give it the ID of where you want to go, what destination, what action you want to trigger, and we'll do all the work for you. Now, this is perhaps a little bit too magical, so you can unroll it just a little bit. In this case, we're using another extension method on view. So from any view that's been created by nav controller, you can actually get a reference to your nav controller just by calling find nav controller, as you might expect, and use that nav controller to call navigate, and just navigate to an ID of a destination or an action in your graph. That's it. Like, under the covers, this navigate is actually doing a lot of work. So the nav controller is talking to what we call a navigator. And so for fragments, we're talking to a fragment navigator that we provide. And that navigator knows everything about, oh, you called navigate. I know what fragment you're going to because you gave us your class name. And it's going to build all of the fragment transaction for you. It's going to call add to backstack. It's going to do all the things that you told us to do by putting that information in your navigation graph. So if you had pop-up to, it's going to do all of that sort of stuff. Transitions, all of that is in this one line of code. And all of it can be determined either programmatically. We can add additional options to this method, or something that you determine ahead of time as part of your navigation graph. But for a lot of these kind of places, it's not actually just a navigate, right? You have some information to pass to the next source. So for this, you need to pass a bundle of information. So here we're passing a string and an int, and we're using our nice helpful bundle of from Android KTX. And it works. It's fine. This is really useful for a lot of things. But at the same point, it's not very safe. If you do a mistype here, like, what are you going to do? So we really want to make this a lot easier. Sergey's going to talk about what we did here.
Yeah, we built something called Save Ours Gradle plugin. And it will help you a little bit. But first of all, let's see what we are trying to resolve. And let's go back to our sample. Our fragment, help fragment, where we try to navigate, actually requires us to pass screen name argument. And optionally, you can pass a category which has integer type. And let's go back to the calling side. Well, in our slides, we made everything correctly. We pass screen, and it has proper type. We pass category, it has proper type as well. But actually, during refactorings or some other modifications, you can forget to pass screen name. It will result in runtime exception. And don't get me wrong, it's super easy to fix. But it feels annoying. It feels like, what am I, JavaScript developer? Why is this compile time check? Like, I don't know. So yeah, we decided, OK, now we have this navigation graph. Let's put all about navigation there, including the arguments of your destinations. So let's see how it looks like in XML. And it's super simple. We just specify your argument name, its type. Additionally, you can specify default value. It means that your argument is optional. And this allows us to build tooling that once you have an action that leads to this fragment or other action or activity, we can check and make you to pass proper arguments. So let's take a look how it looks like with our Gradle plugin. Now, to navigate, we use this special object, which instead of passing ID and a bundle, of course, internally, this object incorporates the same ID and same arguments. But to get that object, we use a home fragment direction class. It's generated for you. Now, it's just a fragment name plus suffix directions. And this class has static methods for every action defined for this destination. And those static methods make you pass required arguments. So in our case, it makes us to pass home argument there. And yeah, optionally, you can later set up your other additional arguments. And everything is type safe. And receiving side after that is super simple. You have this Pojo that they generate for you. It's args class. So for our case, it's half fragment args. And it just has all your arguments that you defined in a type-safe manner. And from this relatively small life improvement, we go to the bigger one, which is deep links.
Yes. So deep links are traditionally something that Android has supported for the longest time. So you can add intent filters to activities and take over a web URL, as well as deep linking is super useful for notifications and things like that to link back into your app. But this gets a lot more complicated as you get a more complicated app, like how you structure these things and how you say, all right, I need to build a notification. What is all of the code that's needed to actually get into the correct place in my app and pass the right kind of information here? So for navigation, we really made deep linking kind of a first-class citizen in our structure. So there's really two kinds of deep links. The explicit kind, so these are things like for notifications, app shortcuts, app widgets, and the new actions and slices, things that are things that you create and are usually pending intent-based. So these are all things that you're passing to another app or to the system to say, I want to go to this specific place in my app. The implicit side of things are more around the web URLs and custom scheme URLs. So these would be other apps triggering your app to launch. And we handle both of these for navigation. For explicit deep links, we have a specific class called nav deep link builder. And its sole goal in life is to deep link to a specific destination in your navigation graph by its ID. It's going to do all of that work. It's easy to say, but it's a little bit harder to actually make sure that all works in the system. But if we create a nav deep link builder, you create it with the context, you give it your graph, your destination, any arguments you have, and then you can just call create pending intent. And we're doing all of the work here to create the right synthetic backstack, both within your graph and if you're using multiple activities, your parent activities as well. And we're going to pass that along and create the correct intent that gives you to the right place when you trigger this intent. And then you just pass it through to your notification. You don't actually need to do more than this to get all the correct behavior. For implicit deep links, these are, again, kind of links to web URLs, right? So in this case, instead of it being something that you create programmatically, it's information you include in your navigation graph. So here, we're adding a deep link element, just like we added the arguments and actions to our graph. These are just a deep link. And of course, you can do all of this in the visual editor as part of the properties for a destination. And it's really just as simple as an app:URI. And you pass in a URI. Now, this is a static URI, which is boring and dumb. And there's only so many apps that have just one URI they do. So we, of course, support some wildcards. So if you want to do a .star for a wildcard, totally supported. If you want to fill in the arguments for your destination, you can actually use curly braces. And we'll parse the URL for you and extract those values and give them to you for your args. So again, kind of in that same type-safe args, now you can get those directly from your URL and not have to re-parse things. You already know what this is supposed to be. Similarly, you can kind of combine the two. If you want to make more complicated patterns, totally can. We also have support for auto-verify if you're using app links to skip that disambiguation screen. We wanted to make sure that you could do the same kind of thing if you're using navigation as well. And you'll note here that we left off the HTTP HTTPS. So what we're doing here is actually doing both. We're saying HTTP, HTTPS. Now, I assume your servers are all HTTPS, but you can't really control the URLs that other apps are including to your app. Maybe they accidentally took the S off of your URL, and we still want to support both of those. So we use this just as a convenience method instead of having 2 lines to have 1. And of course, it also works with custom schemes. So if you have your own scheme that you've set up specifically for your app, you can also attach those to deep links. Now, the best part is we've kind of worked across the tool space. So besides just the navigation editor, we've also worked with the manifest merger team. So you can add just a single nav graph element to an activity in your manifest, pointing to your graph. And all of the deep links in that graph will then get expanded out to be the correct intent filter. We'll build all those for you. And if you go to the manifest merger view in Android Studio, you actually see the exact line from your navigation file that generated that intent filter. So this means that we now have a single source of truth in your navigation graph that you know this is not going to get out of sync with what you expect. It's not going to get out of sync as you change argument names in your XML file. All of this is kind of one central place to do things. And we think this is a lot easier for basically all of the implicit deep link kind of cases. Of course, we do things where this is all action view URLs, as they would be for web URLs. So you can see it's added directly to the line. And if you have multiple of them, it'll actually tell you exactly what line. If you have multiple graphs associated with different activities, those will all work just fine. So one of the other subjects that is really important to all of architecture components is testing. And testing of navigation is very hard. And this is something that we're going to continue to look at over the alpha period, and we really want all of your feedback as well. But I wanted to kind of discuss what we think testing in a navigation world should look like. So a lot of it is if all of the links between your destinations are through navigation, then it's a lot easier to test a destination in isolation, right? You can test each destination by itself and then test just the outgoing edges or just the incoming arguments and not have to deal with, oh, did it actually do the right fragment transaction? Because we can test that just at the navigation controller level. So this is something that we are going to spend a lot more time on. And in the fragment talk yesterday, we actually talked about really trying to make fragments themselves much more testable in isolation. So it's kind of a package deal where we are trying to build testing into navigation controller, but then also trying to build testable destinations as well. So you might be interested to do something right now. So if you're at an espresso test, and you want to test, oh, when I navigate to something, does it go to the right place? Well, we actually have a add-on navigator navigated listener. So you can actually hook it up to the nav controller's navigator and get a callback of, oh, did you go to the right place when I click this button? So this is one method that we found pretty successful in kind of testing things completely black box outside of things. Obviously, if you want to inject a nav controller or use any other method, those are also perfectly valid ways of kind of setting things up. So what can you play with today? And what could you play with? You had 2 days. You must have looked at it, right? It is in alpha right now. 1.00 alpha 01. We're giving ourselves a long runway of bug fixes and improvements here. And it really comes down to 2 main artifacts: the navigation fragment, which includes the navigation runtime dependency as a transitive dependency, and also the nav host fragment and the fragment navigator that you need to use fragment destinations. as well as the navigation UI dependency, which has those static methods. And for every one of the dependencies for navigation, we have a -KTX version of them if you're using Kotlin. So we really tried to make Kotlin a first-class citizen in the navigation world, especially for some of the things like if you are doing programmatic graph construction, like say you're reading your whole navigation graph from a server, we have a Kotlin DSL as part of our Kotlin extensions to make that a lot easier if you're using Kotlin. So there is more to do, and I'll have Lukas talk about kind of where we're going.
Yeah. One note, you are going to need Android Studio 3.2 Preview Canary 14 to use this. And please do download it and try it out. There's a lot of great stuff there. So this is obviously going to become a really core part of not just architecture components, but Jetpack overall. So with Jetpack, we're going to take the same approach we took with architecture components, a sort of blank sheet of paper, what do we want the Android developer experience to be, and apply that much more broadly. And navigation will be eventually part of the default experience. So when we get to stable, then creating a new project in Android Studio is going to, by default, start you up in the nav editor. And it should be a pretty great world. And Jetpack is available for you to try right now. Right now, it's sort of got a much nicer introduction to what all the key pieces of Android development are. So it's a much easier on-ramp. And we're looking forward to expanding this story over time. There are more talks for you to go to, a lot more detail on Android KTX and paging. Paging in particular is a really cool, deep library that does a lot for you by tying together different pieces of architecture components in Jetpack. So I encourage you, if you ever have a list view with more stuff than you can hold in memory at any given time, you really want to go to this paging talk. And we want your feedback. We want your feedback on this session, first of all, but more importantly, we want your feedback on the navigation component. The reason that we're launching to alpha is not because we think that this is sort of, really untested and untried. We've actually done a lot of pre-release testing of this, but we were launching it to alpha because we want to get a lot of feedback from the community on it before we lock down the API and switch over to beta. So this is a great time for you to try it out. Tell us what works for you. Tell us what doesn't. And either communicate with us directly or on our public issue tracker. We would love to hear from you. Your feedback has been really critical in every point of this journey in making sure that we're attacking the right problems with the right solutions. So please do try it out and tell us what you think. And thank you.